So let's finish this. So we've got sodium. It's got one valence electron. Its configuration is neon 3s1. If it could get rid of that, it would be just like a noble gas. Group 1 and group 17 are similar in reactivity. In both cases, there's only one electron standing between them and being like a noble gas. Once you add 2 or 3 electrons between you and being like a noble gas, it takes you a little bit more energy to overcome that getting rid of 2 or 3 electrons. Getting rid of or gaining 1 electron is pretty easy. Hence, group 1 and group 17 are really, really reactive, really unstable. Does that make sense? Yeah. Okay, so now looking at the example of sodium, cut that. For sodium, this is a neutral sodium atom. It's pretty unstable as it is. If it could lose an electron and be sodium 1 plus, it would be really low energy. It would be more stable. But we're not going to talk about that right now because we're talking about electron affinity, which is the energy change when you do what with an electron? Add an electron. So if we try to force an electron onto sodium, and we do this, and we now have a sodium 1 minus, it is in no way stable. You're like having to hold that thing down like a spring. The second that you stop forcing that electron onto sodium, it's going to kick it off. Because it wasn't even stable here. You know, it wants to be here. You're getting it further away from its goal. Does that make sense? Up and down means yes, back and forth means no. 0 to 5, 0, I don't know what language you're speaking. 5, I've got this. Can I just take the test now? 3s, 4s. Okay, that's fine. So the difference in energy between this and this, if this is 100 and this is 10, what do you have to add to 10 to get to 100? Positive 90. So things that are less stable when they have an electron added to them have a positive electron affinity. This would be a positive number because there's actually more energy, it's higher energy, it's less stable when you add an electron. Does that make sense? Okay. Does this help? Okay. Does doing this kind of chart work better than, okay. So you would have to add energy to push an electron onto sodium, where if you were removing an electron from sodium, easy breezy. Yes, no? What questions do you still have? Because I still see people who are like, Okay, well, hold on. Let's finish this concept first, and then yes. Yes, sir.
So if you were working with fluorine, it would be the opposite?
Yeah, if you're looking at fluorine, it wants to gain an electron. If we take this same chart, if we take this very same chart, let me move it over here and shrink it. If you tried to strip an electron off fluorine, this would be a fluorine 1 plus. It would be high energy, less stable. Now you can't even, remember that the energy change that we talk about when we talk about stripping off an electron is what? Ionization energy. Fluorine has got an insanely high ionization energy. It really almost can't be done because it's higher energy, it's less stable when you take off an electron because it wants to gain an electron. Does that make sense? So it's very individual. It's very, and not even element by element, but group by group. Group 1 wants to lose. You can't make them take one, or you can't make them keep one. Group 17 wants to gain. You really can't strip an electron off it because it gets them further away from their goal. Yes, sir?
So, is it okay if I think of it as if group 17 wants infinity, right? They want
Group 17 has a negative electron affinity because the energy change between the neutral atom and the negative ion is a negative number. So this should help you conceptually, but really at the end of the day, you kind of have to memorize that negative electron affinity values mean that it's lower energy once it takes that electron. Positive electron affinity values means that it's higher energy once it takes that electron. So yeah, I mean you can develop whatever mnemonic you want, but I'm not sure what you're saying is technically correct. And I have a hard time saying yes to things that I think might not be technically correct. I'm afraid it'll lead you down a wrong path. Yes, ma'am.
So the lower the energy,
The more stable it is, yes. Yeah. And we'll talk a lot about that in the next chapter when we talk about bonding, because we talk a lot about where things bond, and we talk about energy and attraction. Okay, anything else on electron affinity before we move on? We want to talk about electronegativity. Yes? Electronegativity. Okay, so what is electronegativity? Okay. How closely an atom in a compound attracts the electron cloud. So remember this model, here's the nucleus, and there's this big fuzzy sort of cotton candy cloud, and the electrons could be anywhere in there at any given time. Yeah? Okay. So when you have two of these things that are bonding, let me shrink that just a little bit. Those little red tracks are supposed to represent electrons. And I have another one here that's bonding. It'll have purple electrons, even though we know that electrons are all identical from every atom to every other atom. So when these two things bond covalently, they're overlapping their electron clouds. So some little electrons can go, it's like shared custody. Electrons can now go from this electron cloud to that electron cloud. What happens is some elements, actually, you know what, the shared custody analogy is not a bad one. Some elements have a much better house. They've got better video games. They've got a comfier bed. They've got the dog and the pony and I don't know what else. And so the electrons would like to spend more of their time at the cooler house. Maybe it's the house with fewer rules. Maybe there's no bedtime. Maybe there's ice cream for snack every night. I don't know what there is. But for some atoms, they are more attractive to the electrons in that bonded pair. And so the mass of the electron cloud will actually start to shift, and more of the cloud surrounds one of the two atoms in the bond pair. Because, you know, this is the house with the pool and the dog and the pony and the ice cream, whatever. It's more attractive to those electrons. It's got a better ability to pull them over. That's electronegativity. What's the most electronegative atom there is? Fluorine. Fluorine. And things that are real electronegative tend to also be things that form negative ions. They tend to be the things that form anions, like fluorine, oxygen. Those are all things that are pretty electronegative. They tend to pull the electron cloud in compounds. Does that help? Do you need more on that? Does that work? Okay. Positive feelings about cats. Other questions? Okay. Anything else? Going once, going twice? Okay. If that's all you got, okay, test tomorrow.